Okay, no questions, right? So we have to start with this one. I think it's about the what we call the uh okay.
The transformation.
Yes, yes. Okay. So now, for the translations, what are we have? Okay. Now we know how to move along the x-axis and according to the function, how it works. So we already knew these ones. Now, for the translations, the diagram shows. Now we are going to talk about the translations. So when it comes to translations, it may be either one translation. For example, translation means it can be like either one transformation or else it can be either multiple transformations as well as a combined one. Now, what will happen for the
Okay.
translations? If I go through with these ones, the diagram shows the graph of two functions that differ only by a constant. See, now the x-axis which is drawn with the blue color one, it shows y is equals to x squared minus 2x plus 1. That means for normally how we gonna draw these kind of ones, we differentiate this one as we already done those ones. We did, right? We differentiate it and found out the
Yeah.
turning points. Those parts we did for the O levels, no? So then, according to those ones, according to the those theories, so we know how to find out the turning points, how to find out the whether it's a minimum value or a maximum value. Everything we already know, so that we can draft these two functions. That's correct. Now, okay, let me just maximize this. Okay. Now what we have, when the x coordinates on the two graphs are the same, x is equals to y, x is equals to x, the y coordinates differ by 3 is equals to y plus 3. See the difference in between these ones. When the x,
Hello, teacher.
yes, can't you hear me? Okay, I'm getting a call. Oh, okay.
No, teacher, I lost my connection for a second. That's
Hiroki, can you give me like 5 to 10 minutes? I'll quickly bring something. Someone has arrived my home, so I'll quickly
ah.
take it and get back to you.
Oh,
Be like 5 to 10 minutes. Amme,
okay, teacher. Okay.
Okay, sorry. So here what has happened now when the x coordinates on the two graphs. Okay. So now we
Hello,
already,
teacher.
yeah, we already knew for these kind of functioning. Now how the comparison goes. What do you think? So here we have when the x value is same. Okay, when the x value is same, can we find out a relationship in between y coordinates?
Yeah, so the y coordinate has increased by 3.
Right. So always what has happened to y coordinate? Y coordinates, those y coordinates have been increased by 3. So that means if the earlier y value is y, now the new one is y plus 3. That's how it works. So this means that the two curves have exactly the same shape, but that they are separated by 3 units in the positive y direction. Hence, the graph of y is equals to x squared minus 2x plus 4 is a translation of the graph of this one. So because of that, we say that this the second graph. Second graph is a translation of the first graph. How we write the translation? The vector, by the vector 0, 3. Because it's only changes the 3 again. It's only changes the coordinate of y. It's not changing the x coordinate. Because
Yeah.
of that, the first part it's remaining same. There's nothing to change. That means 0. And but for the second one represent the y coordinate, the change of the y coordinate, that is 3. Okay. So because of that, we
Okay.
write the vector as 0, 3. Is it clear? So
Yes.
how the key point is works, the graph of y is equals to fx. The graph of y is equals to fx plus a is a translation of the graph y is equals to fx by the vector which 0, a. That's how it is. If it's only changes the y coordinates, then there's nothing in x, there's no any changes on x. Because of that, we can put 0 there. But for the y values, you should mention the I mean the changes. That means here we have to add 3. We have to add 3 now. It would be plus 3. So we
Yeah.
mention in this plus part, then the vector would be 0, 3. That's how it works. Okay. Now look at these two. What do you
Okay.
think? If it's if we have the equation like this, y is equals to x squared minus 2x plus 1, and also y is equals to, now we have x minus 3 squared minus 2 times x minus 3 plus 1. Now what do you think what will happen?
Here, instead of the x, it's been replaced by x minus 3.
Yes. Now it's not changing the y value. Actually, it's changing the x value, right? Because
Yeah.
if the earlier equation, uh, if the earlier graph looks like this, then x minus 3 means actually it's shifting to the right side by 3 units. Along,
Why right side?
yeah,
Since it's
because the red color one is the right side. Yeah, that day also we already,
yeah, yeah.
yeah, if it's x minus 3, that means we need to add 3 to become its x, right? Because here
Yes.
it's minus 3, that means we need to add 3 units to make it as x. So because
Yeah.
of that, what we have to do, we have to take it to the right side in 3 units. Always think for the always compared with y is equals to x squared term, because we have the equation for the y is equals to x squared. If it's y is equals to x minus 3k squared, to become like x squared, we need to add another 3 units. We need to add another 3 units means here we have to move to the right along the x-axis. That's how it works. Is it clear?
Yes.
Okay. Then it says the curves have, okay, these ones now it's already curves, no? So the curves have exactly the same shape, but thus time they are separated by 3 units in the positive positive x direction. So you may be surprised that the curve has moved in the positive x direction. Note, however, that a way of obtaining y is equals to y is to have x is equals to x minus 3 or equivalently x is equals to x plus 3. So this means that the two curves are at the same height when the red curve is 3 units to the right of the blue curve. What do you think how the vector works? How we can write the vector?
This time the y components remain 0 and yeah, the x
Yeah,
components
that
should
means
change.
earlier it was 0, 3. It's only
Yeah.
changed, it's only changed the y value. Now it should be 3, 0. The
Yeah.
vector should be 3, 0 because the first element it shows x and the second element it shows y. So this is how it works. 3, 0. Okay. So hence the graph of I is this one and the vector would be, it's look like this. Now second, this is the second, what we call the translation of that. First one is it's changing along the y-axis. The second one is it's moving along the x-axis. That's how it is. Okay, then that is done. Now, I'll give you an exercise that is, can you try? So this part is, okay, that part you can't do. Okay, so now what do you think? Okay, let's assume like this. So if we have a equation like fy is equals to fx, this is the initial equation.
Okay.
Let's assume we have a equation like f function of x minus a, okay, x minus a plus b, x minus a plus b. Now, this is the initial first equation,
Yeah.
first function. This is the second one. So, this one has been transformed. This one has been translated or transformed to the second one. What do you think? How the vector works? What are the changes?
So
Yeah, what are the
yeah,
changes here?
here the x component becomes a and the y component becomes b. So ab.
Right. Because it has been moved, we have to move again according to the fx, we have to move a units from the x-axis to the right side, and also then we need to move up actually from b units along the y-axis. That's how it
Yeah.
is. Okay, so that one we have to mention the vector like this a b. That is it. Okay.
Oh.
Okay. Now, can you try the worked example 11? We only do the worked example, so you can do the entire exercise leisurely at home.
Oh. Okay, teacher. Okay, teacher.
This one is done, right?
Yeah.
Okay. So you were able to find out y is equals to ax squared plus bx plus c. Then you were able to find out what are the values for a, b, and c as well.
Yes. I just
Okay.
substituted x minus 2 in place of x.
Yes, that's how it works. Then that is correct. Then do the 12th one as well.
Okay. Okay.
Okay, so that's also done, right? Then you were able to
Yeah.
find out y is equals to square root of 2x plus 10 plus 3. That's also done. Resulting graph.
Yes.
Okay, now, okay, can you do the last example, last exercise, I mean PS, practice solid, practice one. On
Okay.
seventh one.
Okay, teacher, done.
Okay, that one also done. It's clear, right? How to do this one? They have given the
Yeah.
equation. So here from the x units, units along with the x-axis. This one is for the y coordinate side. එතකොට units which we have to move along the y-axis. එතකොට ඒක තමයි ඒක. That is done. Now those ones are for the translations. No? Second part is about the reflections. So here for the reflections we have, reflections means it's kind of a mirroring. When it comes to mirroring,
Yeah.
now here for the reflection, the initial whatever we called initial function was y is equals to x squared minus 2x plus 1. Okay. Then we have the what we call, okay, let's assume we have the second function or the second equation as y is equals to minus x squared minus 2x plus 1. Now, what do you think? What has happened here? One
Like
is,
plus or
yeah,
yeah, the first one's plus, second one's minus.
yes, if first one is y, actually the second one will be minus y, right? So එතකොට
Yeah.
both ones are equal so that we can find out a relationship in between. We can find out a relationship, or we can find out a relation which we call y is equals to minus y. That's what we have for the same x values, because x values are not changing at all. X values are not changing at all. So for the y values, we can rewrite this as y is equals to minus y. Now, what will happen here? For these type of ones, we call them as fx, I mean y is equals to minus fx is a reflection of the graph y is equals to fx, because the y values are for the same x values, only the y values are changing. That means y values are getting what we call getting negative, like opposite වෙනවා වගේ case එකක්. It's mirroring. That's what it is. Is it clear?
Yes.
Earlier, we talk about the translation. When it comes to translation, it was moving along the x-axis as well as along the y-axis. But here for the reflections, it will be for the same for the same x actually, for the same x, the y values will be changing. Y is equals to minus y. If we can write like this, then it's a reflection of the previous initial graph. Is it clear?
Yes.
Okay. Now this one is mirroring along the mirror line would be actually the x-axis. Okay. Now what
Yes.
do you think if it's mirroring along the y-axis? Y-axis එකෙන් දෙපැත්තට හරියට යනවා නම් then what will happen? Again, I would say like the mirror line would be the y-axis. X is equals to 0 line. Then what will happen? Then it would be actually, so here see the difference. So now consider the two functions. One is x squared minus 2x plus 1. The other one is y is equals to now. Previously කරපු එක වගේ, if we think about the second one also, what will happen? X should equals to minus x, no? If it's mirroring along the y-axis,
Yeah.
එහෙනම් x කියලා කියන එක අනිවාර්යෙන් minus x වෙන්න ඕන. So what we normally do, we just replace this x values along the, again, we just replace these x values with minus x. හරිද? a minus
Yes.
x එකත් එක්ක මේක replace කළා y is equals to x squared minus 2 times minus x plus 1. Is it clear? මේ
Yes.
විදිහට ගත්තට පස්සේ we obtain the second function by replacing x by minus x in the first function. So the graphs of these two functions are demonstrated in the diagram. So if you look at this, here you have the here you have the mirrored one. Make තමයි a mirrored one along which one? Along the y-axis. දැන් මේක බැලුවහම හරියට symmetric වෙලා තියෙන්නෙත් y-axis.
Yeah.
So that's what we have. Is it clear?
Okay.
So the opposite side
Yes.
would be of the y-axis. The curves are at the same height. Now what will happen? Earlier the x values was equal. X values were equal, but the y value got changed. But here, y values are equal, but the x values are positive. Positive, I mean, it would be opposite. That means actually x value is equals to minus x. That's how the relationship works. So this means that the
Okay.
heights of the two graphs are the same because all the y values are same. Y values same, but what will happen with the
Yes.
x values? X values are duplicating mirroring. So the same, when the red graph has the same horizontal displacement from the y-axis as the blue graph, but is on the opposite side of the y-axis. Hence, the graph of y is equals to minus x squared minus 2 times minus x plus 1 is a reflection of the graph of y is equals to x squared minus 2x plus 1 in the y-axis. That's what here we have. Is it clear?
Okay.
Okay,
Yes.
so can you do one thing? Can you read only the reflections part at once up to this point until the key points? Just read whatever it says because for the
Okay.
yeah, only the reflection part translation, I know that's clear. Uh, we can think about with the movings, no, but for the reflection, just
Yeah.
read at once. වාහනේ තිබ්බොත්.
Okay, teacher.
Okay, that's also done. So that is it. Then, hmm, okay, shall we do the worked example? 13th one? No
Okay.
questions, right? On this, whatever we call the no, the mirroring or the reflection, no questions, right? It's clear.
No, teacher. Yeah, yeah.
Okay, then the 2.13 one. Just do the worked example.
Okay, teacher.
Okay, that one also done. The both the part A and the part B?
Yeah, yeah.
Yeah, both are done. Okay. Now for that exercise, we have only three questions. Reflection and given translation. Find the equation of. Okay. Only the last question. Third one. Then we'll move to the stretchings. Stretches.
Good. Okay.
Yeah. Only the third one.
Okay, teacher.
Okay, that one also done. Then let's move to the next part. That is what we call the stretches. So now up to this point, so far up to this point, we did the translations and also the reflections. Now it's about the stretches. So when it comes to stretches means anyway we are like adino wage එකක් නේ. Then what will happen here? So the
Yeah.
diagram shows the graphs of the two functions. The blue color one is y is equals to x squared minus 2x minus 3. And for the second equation it's for y is equals to 2 times x squared minus 2x minus 3. Now what does those two reflect? So the blue color graph is this one, and for the red color graph is this one. What do you think?
So the red color graph is kind of doubled.
Yes, doubled means the y value has been doubled, right? Y value
Yeah.
doubled. That means actually for the same x-axis, for the same x values, but for the y values have been doubled. When x is equals to same x, so here
Yeah.
x value hasn't changed, but what has happened for the y value? Y value has been doubled up. Y value has been doubled up means it's actually has been what we call, it's actually has been stretched. Okay, අර
Oh,
එක්ක දෙපැත්තට එක්ක හරහට. So this one now along there, again, it has been stretched vertically, but maybe sometimes it has been, maybe sometimes there might be some questions or some problems where we can see that it has been stretched along, stretched through the x-axis as well. Anyway, so now x-axis means actually the horizontally. So now this one is stretched vertically. Now here what has happened? So this means that when the x coordinates are the same, so the red curve is twice the distance of the blue graph from the x-axis. So all these distances have been doubled up. So then that means, actually that means what we have stretched along these ones. Now, okay, hence the graph of y is equals to 2 times x squared minus 2x minus 3 is a stretch of the graph of y is equals to x squared minus 2x minus 3 from the x-axis. We say that it has been stretched with stretch factor 2. There you should know what is this stretch factor. So stretch factor is 2 now. If the earlier function was y is equals to fx, now the new one would be y is equals to 2 times fx. This is the new one. Okay. So the y value has been doubled up. So this stretch can be done in 4 ways. Note, there are alternative ways of expressing this transformation as well. One is a stretch with scale factor 2 with the line y is equals to 0 invariant. That means with the y is equals to 0 means x-axis. So here we have a stretch with, now here the scaling factor, here the stretching factor. Again the stretching factor, now the vertical stretch. See, now this one is y is equals to 0 invariant. This
teacher, what does invariant?
Invariant means, okay, invariant means, let me explain you the invariant with an example. For the invariant means, actually it's not changing without any changes. So that's what here it says. A stretch with scale factor 2 with the line y is equals to 0 invariant. Normally invariant means Now here also the x values are not changing, no. That
Yeah.
means the value x values are invariant. But again, then make it may y is equals to 0 means what? Anyway, the x-axis no. So x-axis
Yeah.
won't be changed. X-axis is fixed. හැබැයි අර අනිත් පැත්තට ස්කේලින් ෆැක්ටර් එක දෙකක් වුණාම උඩටයි පල්ලහැටයි ඇදෙන එක තමයි වෙන්නේ.
Yeah.
Okay, that's what here it says. Normally, invariant means it's not changed. Change වෙන්නේ නැහැ කියලා කියන එක තමයි එතනින් කියන්නේ. Okay. Then we have key point 2.11. So, okay, this one. The graph of again A වලින් වැඩි කරනවා. It's like that. අර scaling factor එක 2 නම් 2 times fx කියලා කියන එක ගත්තොත් is the stretch of the graph y is equals to fx with stretch factor parallel to the y-axis. This is for the parallel to the y-axis. Now what it says? Note if a is less than 0. දැන් මෙතන තියෙන එක is greater than කියන්නේ මෙතන තියෙන එක is a positive value and
Yeah.
also it's greater than 0 value. But what will happen if it's a fraction? Fraction means මේ මොනවද ඒකට කියන්නේ a කියලා කියන එක negative value එකක් නම්. Now these ones are නම් a කියලා කියන එක is a positive value. What do you think? What will happen if the a value becomes a negative value? Any thoughts?
Then it will be smaller than the original one, right?
It will be smaller and also it will be turned to the other side.
Opposite. Yeah, opposite.
Opposite වෙන්නත් ඕනේ, but here it hasn't. Yes, positive scale. Yes, it would be a reflection. See, reflection means it's mirror.
Yeah.
එතකොට මොකද වෙන්නේ අනිත් පැත්ත හැරෙන. පොඩි වෙන්නේ නැහැ ඇත්තටම. If it's
Okay.
කියන්නේ පොඩි වෙන්නේ නැහැ means if it's with the comparison of the positive one. Give me 1 minute.
Okay, teacher.
Again, getting a call. Okay. So here it's got reflected. Now what will happen? එතකොට the same thing but it's got reflected. ඒ වගේ එකක් තමයි වෙන්නේ. හැබැයි according to the scaling factor ලොකු වෙනවා නම් ඒක ලොකු වෙනවා. Maybe sometimes it's පොඩි වෙනවා වෙන්නත් පුළුවන්. If it's
Yeah.
less than 1 වගේ factor එකකින් let's assume නිකන් half වලින් වගේ multiply කරනවා.
Yeah.
Then it would be getting much smaller.
All.
I mean, okay. So that's it. Now, here we have, now consider the two functions. This one is the initial function. This one, you should, I preferred, you should read this entire part and අර පොඩි short note එකක් වගේ ගහගන්න මේවට. I mean, how the reflection works. දැන් මේක නිකන් theory එක මාගලක් වගේ දිගයිනේ. So,
Yeah.
better to like topics එක you just equations දෙක දාලා at least how the graph changes කියලා පොඩි short note එකක් ගහලා තියාගන්න, then you can easily recall the things as well.
Yeah. Okay.
So here, now consider the two functions. For the first one, it is y is equals to x squared minus 2x minus 3. Then the second one is y is equals to 2x complete squared minus 2 times 2x minus 3. Okay, by looking at these two, what do you think what has happened?
So here x has become 2x.
Yes, it has been yes. So actually x has become 2x, right?
Yeah.
X has become 2x. Yes, nothing changed on y, but x has become 2x. So here we obtain the second function by replacing x by 2x in the first function. So the two curves are at the same height, y is equals to y when x is equals to 2x. Or equivalently, x is equals to half x as well. Yes, so x is equals to half x means anyway, if we divide both sides by 2, then it will become half of the first x-axis is x value is equals to the second x. No, that's the relationship or the mapping what we have here. So this
Yes.
means that the heights of the two graphs are the same when the red graph has half the horizontal displacement from the y-axis as the blue graph. So hence the graph of y is equals to 2x squared minus 2 times 2x minus 3 is a stretch of the graph. That's how the stretch works along what? Graph of y is equals to x squared minus 2x minus 3 from the y-axis. Earlier it was from the x-axis. No? Now it says from the y-axis. We say that it has been stretched with stretch factor half parallel to the x-axis.
Yeah.
That's what here they have mentioned. Is it clear?
Yes.
Okay. Can you read only the stretches part as well up to this point? Then we'll move to the examples. If you have
Okay.
any doubts, please let me know.
Okay, teacher. Up to now, it's fine.
Okay. Just read the stretches part as well.
Okay, teacher.
Okay. That one is it. Mm, so, okay, that is it. Then, okay, that is it. So here the graph of y is equals to f(ax). It's like function of 2x. So earlier it was function of x. Now it is function of 2x. Is a stretch of the graph, that is y is equals to fx, with stretch factor, that is 1 over a, parallel to the x-axis. So here for the worked example 2.14. Okay, now try to do the 2.14 as well.
Okay. Okay, teacher.
Okay, so the 2.14 also done, right?
Yeah.
Okay. Then anyway, the equation would be y is equals to 20 minus 2x squared. So what you have to do here, the graph of y is equals to 5
Yes.
minus half x squared. Then they said that is the stretched width, a stretch factor 4 parallel to the y-axis. That means again it should go like this. Okay, how it happens? Okay, you should now. Okay, that means y is equals to 5 minus half x squared. No? So what you have to
We
do?
had to multiply the equation by 4.
By 4, right? Yes, that is it. Okay. Then, okay, for 215, 15th one.
Okay.
Okay, that's also done. Then, okay, that's also done. Now you have the, okay, this one also you can do. Now let's move to the, okay, let's move to the, now no need to do these ones, right? You can manage it, I think so. For the
Yeah.
exercise 2G. Okay, can you do
Yeah.
only the last question? I mean the third question.
Okay. Okay, teacher.
Okay, that is done. Now, for the last few sections, here there's nothing new actually. Now we have the combined transformations. So, how these combined transformations work? What do you think? So, here now in this section, you will learn how to apply simple combinations of transformations. So, the transformations of the graph of y is equals to fx that you have studied so far can each be categorized as either vertical or horizontal transformations. Now, what do we have? So here for the vertical transformations, y is equals to fx plus a. If it's a vertical transformation now, we know that x is remaining, x coordinates are remaining, but for the y coordinates, those ones will be changed. So here for the reflection now along the vertical, again as a vertical transformation now, then it would be our y is equals to minus y. That means the total fx function is we have to multiply it by minus 1. That means anyway we have to take a reflection. So then we have the vertical stretch. Vertical stretch means then all together, whatever we did so far, we have narrowed down or summarized it into two transformations. One is for the vertical transformations, other one is for the horizontal transformation. So if it's vertical transformation now, then we have 0a reflection in the x-axis. So for the vertical stretch, factor a. But for the horizontal transformation now, then we have for the translation that is minus a0 and the reflection in the y-axis now it would be, it's not y is equals to minus y. It would be if it's x nung, x value will be changed.
Yeah.
So here earlier it was fx nung, now it's f minus x. So here for the function y is equals to function of ax, the horizontal stretch factor will be 1 over a. This is really important. So it's a summary actually, whatever we have done so far. And also for the combined transformations, we can combine either one or two transformations together and do the final one. Okay, let's see. Go through with this Explore 2.5. It's clear, right, up to this point? I mean, here
Yeah.
the
Yeah.
summary of the previous things, whatever we have already taught. Now only the combination started. So here, now in Explore, okay, check, go through with this one first by yourself. I'll also explain you, but just go through with that.
Okay.
Okay. Now, what they have mentioned, apply the transformations in the given order to triangle T, and for each question, comment each question, comment on the each question, comment on whether the final images are the same or different. Combining two vertical transformations. First one is what? Now, this is the original one. First one is translate 0, 3, then stretch vertically with factor half. Okay. Tell me, if we translate with this factor 0, 3, what will happen?
The y coordinates will move up by 3 units.
Yes, that is there. Then if we stretch vertically with factor half, then what will happen? Can you draw that one? If it's half now or a previously discussed one? 1 over 2 and a quarter?
Yeah.
1. It would be how it works. Even I have to check. So that means actually if they have mentioned that නේ ඒගොල්ලෝ කියලා තියෙන්නේ vertically with factor half, right?
Yeah, that's what. So it's along the
Yes,
y-axis.
that means it's along again vertical transformation එකක් නේ. So here
Yeah.
A would be half, right? Then
Yes.
then is it narrow again? Is it narrow downing or is it getting wider? Is it actually
Uh,
stretched or එහෙම නැත්නම් අර is it expand? ඒ කියන්නේ
no,
එළියට
it's not stretched. It's gonna be smaller, like but
it's
vertical.
gonna be smaller. Yes, it's gonna be smaller. Yes. තව අර කෙට්ටු වෙලා පොඩි වෙලා තියෙන්නේ නේ.
Yeah.
Yeah, it would be like that. Now the second one would be stretch vertically with factor half, then translate. Okay. Then පළවෙනි එක first they ask us to translate this one and then do the stretching thing. Now for the second one, they ask us to do the stretch thing first, and then do the whatever we call the translations. What do you think? Shall we do this actually? Can you draw this triangle and try to do that? Do
On
you
a
have
graph
a squared?
paper.
Do you have a squared paper?
Yeah, I do.
Okay. Then can you draw this first? So then I can draw it like a little bit bigger with අර මේගොල්ලෝ ඇඳලා තියෙනවා වගේම if you have a proper graphing paper then draw this in the middle so that we can අර හරියට වටේ transformation එකට යන්න පුළුවන්. Otherwise maybe sometimes we won't the space will not enough.
Okay.
Enough. Only the first one.
Okay.
Como kadang-kadang mereka mata para DKI banget. Bandung DKI deh. Oh, ada dia ada nggak aja ya kan? Này chị mà được, chị có đẹp nè rồi à. Ah,
Okay, teacher. Okay, teacher. Done, teacher. Hello, teacher. Done. Yes, sir.
Okay. So, Okay, that is done. So, did you like do the first one?
Yeah, I did the first one. I did part one and part two. Both of them end up with the same.
Ah, right. Both of them are same, right? Investigate for other pairs of vertical. Okay, that is done. What about the second one? Combining one vertical and one horizontal transformation. Now, the first one is combining two vertical transformations together. Now, the second one is combining one vertical and one horizontal transformation together. How it,
Okay, shall I do that?
yeah.
Okay, teacher. I did the second one as well.
Okay. That one also, it's clear, right?
Yeah, the same. I mean,
Same. Okay.
yeah, the same picture there.
Okay, for the last one, we have the combining two horizontal transformations. So earlier it was two vertical transformations, then one vertical and one horizontal one. The last option would say two horizontal transformations. Now for the two horizontal transformations also will be same actually, but you can just try those two. I'll explain the last two theories as well. Then you can go through with the entire lessons and complete the remaining exercises. So for the last one would be combining two vertical transformations. No? So now this one you already did. This was kind of an error. Before in deep going to the theories, they are like let us to do these exercises. That's what they do here. Now for the theory part, how it works, combining two vertical transformations. We will now consider how the graph of y is equals to fx is transformed to the graph y is equals to afx plus k. This can be shown in a flow diagram as for the first one is that is stretch vertically factor A multiply function by A. So now how it works? Now the equation what they have given was A times fx plus k. Now here
Yeah.
combining two transformations. No? First transformation is first vertical transformation would be multiplying by A, and then again we need to move it again. Multiplying by A means actually the stretching part, and then we have to move the entire curve along the y-axis, I mean vertically, k units upwards. That's what there we have. Okay.
Yeah.
Now, how it works, then first we have to take the fx function. Then we need to stretch vertically by factor A. And then we have to translate it with 0k. The x-axis won't change, only the y-axis will be changed. Okay, that's what here we have.
Okay.
For these
So
type,
teacher, how do we stretch linear graphs? Now curved graphs we can. Linear graphs, how do we stretch?
linear graphs actually, yes, we can know if it's y is equals to x, and the second time it would be if y is equals to 2x. Now what will happen? Again,
Ah, yeah, yeah.
y is equals to x, the line will be like this. Now for the same x values, what will happen? Now how it say? If it's 2x now, then actually the it would be, we can
Yeah.
find out a proper stretching there, but we can do that one as well.
Okay.
Yeah, it's actually now what will happen? Now, oh, how would say then? X has been like 2x now. It has been like, එතකොට x ගේ value එක 1 කියලා දැම්මම again y value එක අර stretch වෙනවා means it's getting much closer to y axis and තව අර ඒක it's making lengthier as well. තව දික් වෙනවා. අන්න එහෙම case එකක් තමයි එතන තියෙන්නේ. So again it can be done. But what you
Okay.
can do, you can like apply the coordinates and check also how it works.
Okay.
Okay, then that is there. So this leads to the important result. So here for the key important, okay, this one is there. How we combine two horizontal transformations. Now the first part is two vertical and the next one would be two horizontal transformations. If it's two horizontal transformations, now first we need to do the translation and then we can do the factoring. That means the stretching part. So the equation would be y is equals to function of bx plus c type of one. That's what there we have. Okay. So earlier y is equals to function of bx plus c type of an equation. That is for the combining two horizontal transformations. Okay.
Okay.
Then for the last one, here we have the worked example as well. See, so now y is equals to fx. So for the stretch the graph, how it works, y is equals to 2 times fx minus 3. That means here we have to stretch the function by 2. That means the scaling factor is 2 and also it would be stretched along the vertical axis. And then we need to move down it by 3 units.
Yeah.
Here, if it's a y is equals to, if the equation is like this, again a function of bx plus c now. then that means it's a kind of a horizontal transformation. Hari.
Yeah.
So then, see, this is what we have. Okay, so now for the worked example 2.17 also, here we have y is equals to x squared, and then the diagram shows the graph of y is equals to x squared and its image. So y is equals to gx after a combination of transformation as well. Okay, anyway, this also will be like that. We can do the transformation according to that. See, it's not getting stretched. It's narrowed down. That's all.
Yeah.
Okay. Then, okay, that's it. 2.8. Okay, that's all for the complete second chapter as well. We are done with the second chapter. Is it clear for you what we have done so far?
Sorry, teacher.
Is it clear for you what we have done so far?
Yeah.
The second
Yes,
chapter
teacher.
also done. Okay, so what you can do before doing all these exercises, first go through at once for the entire lesson, the theory parts, and then start the remaining exercises as well as the leftovers what we have as the examples. So those ones
Yeah.
you do, and the worked examples also you can do. Okay?
I think teacher 2 hours are enough, right?
yeah ඒක තමයි ඊට වඩා වැඩි වෙනකොට I feel like it's අර ඔළුවට යන්නෙත් නැහැ අනිත් එක අර ඉස්සර වගේත් නෙමෙයි because we have too much facts no ඒ කියන්නේ අර for the A
Yeah.
levels ඒවත් we haven't done the transformations translations everything at now it's almost ඕනේ 2.5 hours වගේ කරලා I also felt like that yeah 2 hours are enough so
No, no, teacher. I meant like to cover the this thing, like to
yes
cover the this
yes
thing. two
yes
hours are enough.
Yes, yes. So anyway, it would be like that. So just go through with all the theories and then do the exercises. Whatever you check with the answers as well. There they have the අනිත් එක තමයි අර මම දැක්ක site එකක තියෙනවා. They have the solution book as well. Were you able to find out? ඒගොල්ලෝගේ මම හිතන්නේ Edexcel also they have a separate solution
The
book.
solutions are there at the end of the book, teacher.
Edexcel
Yeah,
one,
it's
we have
there,
a
teacher.
separate, yeah, for the Edexcel one now, we have a separate solution book as well with the steps and everything. Check whether, I'll also check for the Cambridge also whether they have a separate solution book කියලා. පිටිපස්සේ ඔක්කොම steps නෑ නේද? We
No,
have
no, just the answers, not the
yeah.
steps.
So there, I think for the solution book, they have given all the steps as well. I'll also search for that. If I found it, I'll send back to you. එතකොට එකෙන් ඔයා උත්තරත් බලලා and also you just check for the answers as well. No worries, we have enough time. So හෙමින්
Yeah,
යන්න විතරයි තියෙන්නේ. Take all the theories to your mind. ඒක තමයි ඉස්සෙල්ලම වෙන්න ඕනේ. Okay, because these ones we need it for the further maths as well no. එතකොට
yes.
base එක we have to have if we have the correct base on these ones, then we can easily do the further maths as well. Okay?
Okay,
Okay, then that's it. Thank you for joining. See you on.
okay,
Bye.
teacher. Good night.
Good
Thank you. Bye.
night. Good night.